Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome to the TV learning program. This is Teacher Pasco and I will be teaching chemistry Senior 2 students. In the previous lessons, you discussed the different types of chemical reactions. And today we are continuing with the same unit. And here I have an exercise for you. Before we start our new lesson, you have a revision exercise. Complete and balance the following equations and identify the type of each reaction. We have magnesium reacting with hydrochloric acid and sodium hydroxide reacting with sulfuric acid. Remember to put the state symbols on each reactant and product. You have 1 minute. Good. When magnesium reacts with hydrochloric acid, what do we produce? We produce magnesium chloride and hydrogen. Now, let us look at the state symbols before we go on balancing. Magnesium is a metallic element, so it is present in the solid state. So it is solid. And hydrochloric acid, being an acid, it is dissolved in water, you remember. So it will be in aqueous state. And magnesium chloride is a salt, an ionic compound, which is soluble in water. So being soluble in water, and here we have the aqueous state, to mean that there is some water in the reacting mixture, then magnesium chloride will be in aqueous state. And hydrogen is a diatomic element which is present in gaseous state. Good. In gaseous state. And is our equation balanced? Let's have a look. We have one magnesium atom, and here we have one magnesium. For chlorine, here we have 2 chlorine, but in the reactant side, we have 1 chlorine. For hydrogen, we have 2 hydrogen atoms in the molecule, but in the reactant side, we have 1. So we need to balance the hydrogen and chlorine in the reactant side. It's very simple here. You just put there 2. So now we have 2 hydrogen, 2 chlorine and 2 hydrogen, and our equation is well balanced. Number 2, we have sodium hydroxide reacting with sulfuric acid. It is a base reacting with an acid. Do you remember how we call that reaction? When a base reacts with an acid, it is a reaction we call neutralization reaction. There is neutralization reaction, which is a type of double replacement reaction. If we go back to this equation, how do we call it? What is the class of this reaction, or the type of this reaction? Magnesium has replaced hydrogen from hydrochloric acid. So it is a single replacement. Single replacement reaction. Single replacement reaction. Now let us complete this equation. When a base reacts with an acid, what do we get? We get 2 products. The first one is a salt, and the second one is water. So here we produce sodium sulfate plus water. what are the state symbols of our reactants and products? Sodium hydroxide is an ionic compound, so to react with the acid, it should be in the aqueous state, so it is dissolved in water. The acid is also in water. And sodium sulfate, it is a soluble salt which is also dissolved in water, and water here is in the liquid state. And remember, the type of reaction here is neutralization reaction. Now, there is another type of classification maybe you didn't talk about, but which is very important. And all the reactions you have studied, they can be classified into two types depending on the temperature change when the reaction is taking place. When all reactions are taking place, there is a possibility that the temperature of the reacting mixture can increase. And there is another possibility that the temperature can decrease. And because of that, we get two types. Type number one is endothermic reaction. Endothermic reaction. And the second is exothermic reaction. But is this really possible when we carry out the reactions? Let us try. We have water here, and we will use this water to make an acidic solution. And this is our thermometer we are going to use to check if the temperature changes really when the reaction is taking place. We also have, this is the ordinary thermometer, and this is a digital thermometer. We also have water in another beaker, and we will use this water to make a solution of potassium iodide. Potassium iodide is an ionic substance. We will dissolve some potassium iodide in water and measure the temperature to see what happens. Will the temperature increase or it will decrease? Whether it increases or decreases, it will allow us to classify the reaction or the process as being endothermic or exothermic. Now, let us start with the formation of an acidic solution. The acid we have here is sulfuric acid. You should always be careful when handling chemicals. Here we have our digital thermometer, and when I add, of course, the water we have here is at room temperature. So the temperature, of course, will be below 30 and something around 25 degrees. But what will happen when we use our digital thermometer to measure the temperature when we are making this solution? Let us have a look. Do you see the temperature change? Can you see the temperature change? I'm reading 40.3. The temperature now is 40.3. So if it is increasing from room temperature, which is around, the temperature which is around 25 degrees, and now it has become 40.3, it shows that dissolving an acid in water is a process which increases the temperature of the reacting mixture or of the solution. And how do we call that reaction in which the temperature increases? We call it exothermic reaction. Exothermic reaction, then, it is a reaction in which the temperature increases when the reaction is taking place. So, exothermic reaction is a reaction which produces heat. When it is taking place, it produces heat, and that heat which is produced is the one responsible for the increase in temperature. Now, what happens when we will use both thermometers, and here we have potassium iodide. The temperature is around 25. You can see the blue line here, okay? So the temperature is around 25, 23, 22, something like that. It's below 25. Now, what happens when we add some potassium iodide in our solution, in this water? Let us mix and see what happens as the potassium iodide we have added is dissolving. As our potassium iodide is dissolving, what happens you can have a look. Now look at what temperature the thermometer is reading. Now I have something like 21. It's around 20. And remember when we started, it was 23. So the temperature is dropping. Why is it dropping? It is because our process dissolving potassium iodide in water is a process which absorbs temperature. Sorry, it absorbs heat. So a substance which reacts, or any reaction which takes place with an absorption of temperature, an absorption of heat, that one is called an endothermic reaction. We have some example of such processes. Consider what happens when the alcohol, you remember the alcohol we use in salons, hair cutting salons. When you are feeling that alcohol, when you put some drops of the ethanol on your skin, it feels so cold. Why? Because evaporation is a process which needs some heat to take place. So the heat which is needed will be absorbed from your skin, and then you feel cold, because the process is endothermic. So endothermic reactions, they are reactions which absorb heat when taking place. Endothermic reaction, we have any reaction which absorbs heat when it is taking place. And because of the heat which is absorbed, the temperature falls. Exothermic reaction, it is a reaction which releases heat and then causes an increase in temperature. Now, we know different types of reactions And one of the classifications we have here, the new classification, is the exothermic and endothermic reactions. I want to tell you something. We have been writing equations in the molecular form. We use whole molecules, the compounds in the whole form. But there is a possibility of writing equations in another form, the form we call ionic form. And with the ionic form, we write ionic equations, and that is the new lesson of today. Ionic equations. How do we write ionic equations? We have the rules here. Rules for writing ionic equations. Rule number 1, we have to write a balanced equation with state symbols, just like how we did it. Magnesium hydrochloric acid, balanced equation with state symbols. And secondly, we separate the ions of all aqueous substances. We write the ions in a separate form. For example, here we have magnesium chloride. It is in the aqueous state. Now, because it is in the aqueous state, we will separate the ions forming that magnesium chloride. And number 3, we cross out all free ions present on both sides. We will demonstrate this rule number 3 when we will be working out these 2 examples. And those ions which are present on both sides and which are free in the solution, we call them spectator ions. They don't really take part in the reaction, which brings out some changes. Now, let us try this example number 1. The work example number 1. We have magnesium reacting with hydrochloric acid, and the answer will be magnesium chloride plus hydrogen. State symbols, we have solid for magnesium and aqueous for hydrochloric acid, aqueous for magnesium chloride, and gas for hydrogen. Rule number 2, we separate the ions of all aqueous substances. Let us separate the ions. Aqueous substances we have is hydrochloric acid and magnesium chloride. So our equation becomes magnesium solid. Remember to always put the state symbols plus H positive in aqueous state plus Cl negative in aqueous state, and we produce magnesium 2 positive in aqueous state plus 2Cl negative in aqueous state plus hydrogen gas. Remember, here we have to balance, and because of that, here we have 2, and here we have 2. Now, rule number 3 says we have to cross out all free ions present on both sides. Which free ions that we have which are present on both sides? You can see here we have 2 chloride ions, and here we have 2 chloride ions. Those are the only ions which are present on both sides. Don't be confused. The magnesium we have here is very different from what we have here. This is in the solid state, but this is in the aqueous state. So you have to consider the states. Here we have 2H positive in aqueous state, but here it is hydrogen gas. So they are very different. We will not cross them out. So here we have the chloride ions which are removed and the chloride ions which are moved, and our ionic equation becomes magnesium reacting with 2H plus aqueous to produce magnesium 2 positive with hydrogen gas. Let us have a look at the second equation. The second equation, here we have sodium sulfate and water. Water is in the liquid state, aqueous, aqueous, and aqueous, and we balance. We separate the ions. Here we have 2 sodium aqueous plus 2 OH negative aqueous plus 2H positive. All the substances we have here are in the aqueous form, so we separate the ions. And here we produce 2 sodium positive aqueous plus SO4 2 negative aqueous plus H2O liquid. H2O liquid. And then the ions we have on both sides are, you can see we have sodium and sodium. We have the sulfate ion, and here also we have the sulfate ion. So we cross out sodium and sodium, the sulfate ion and the sulfate ion, and our ionic equation becomes 2 hydroxide ions plus 2 H plus to produce 2 H2O. And that is our ionic equation. Now here we have more examples to be worked on. We have magnesium reacting with HCl. We did this one. And the second one is potassium iodide reacting with lead nitrate. Try this one. Let me give you like 2 seconds, and you try it 30 seconds. Remember, you complete the equation, you balance it, don't forget the state symbols, and you separate the ions for all substances in the aqueous state, and you cross out ions which are present on both sides. Okay. Potassium iodide reacting with this, we produce potassium nitrate plus lead iodide. This one is present in the solid state because it is an insoluble salt. This one is present in aqueous state because it is a soluble salt. So you should revise the rules of solubility, which substances are soluble, which ones are insoluble in water, to know which substances will be in aqueous state so that you can know which will separate the ions and which ones will be removed, crossed out. Here we have aqueous, and then we balance. We have 2 potassium aqueous plus 2 iodide aqueous plus lead 2 plus 2NO3 aqueous, and we produce 2 potassium plus 2NO3, the nitrate ion aqueous, plus lead 2 plus aqueous, and 2 iodide ions aqueous. We said this one is solid, so it will not be separated because it doesn't dissolve. So we have iodide, lead iodide, which is solid. We have free potassium and free potassium, so they are crossed out. We have the nitrate ion and the nitrate ion, so they are crossed out. And our ionic equation becomes 2I negative plus lead 2 positive aqueous to produce lead iodide, which is solid. Now we have some exercises here. I will correct 2 of them, and then you will continue by yourself, and here there is also a homework that you will try. Zinc plus nitric acid, how does it change? We have zinc, nitrate, aqueous, this is solid, plus hydrogen gas. And this one, which is aqueous, and the aqueous, then we have zinc solid plus H positive plus 2NO3 negative, and we produce zinc 2 plus 2 nitrate ions and hydrogen gas. H plus is not present on this side. So what we have that is present is the nitrate ion and the nitrate ion, and our ionic equation becomes zinc plus 2H positive to produce zinc 2 plus and hydrogen gas. What happens with silver nitrate and sodium chloride? We have silver chloride, which is solid, and sodium nitrate, which is aqueous. This is aqueous and aqueous because our both substances are soluble in water. So we have silver positive plus the nitrate ion plus sodium positive, the chloride ion, to produce silver chloride, which is solid, sodium ion, and the nitrate ion. The nitrate ion is present in the free form here, and sodium is also present in the free form, so we cross them out, and our ionic equation remains silver reacting with the chloride ion to produce solid silver chloride. So that is how we write the ionic equations. Remember, we write ionic equations for single displacement reaction or single replacement reaction and double replacement reactions only. For other reactions, it's not possible. So here you have more exercises to try, and here we have the homework you will do when you will get time. Hydrochloric acid reacting with sodium carbonate, sodium sulfate reacting with barium chloride, copper chloride and silver nitrate, zinc and nitric acid, and iron sulfate plus potassium hydroxide. And lastly, you will distinguish endothermic and exothermic reactions. This is the end of our lesson, and I thank you very much for your attention, and I hope to see you next time for our next class. Thank you very much.